Okay, so we want to show that this version of Maxwell's equation in terms of the four potentials is exactly equivalent to these two Maxwell's equations in terms of the electromagnetic tensor. So let's do this one first, and we expand out our definition of our tensor. So we're summing over alpha, beta, and gamma, and this term in here is symmetric in terms of gamma and alpha because derivatives commute, and this term here is symmetric in terms of gamma and beta and derivatives commute. And when you sum over an antisymmetric and a symmetric thing, then you get zero, which I can show explicitly by writing this thing in two ways and this thing in two ways and showing that they're equal and opposite. So if I write it as like that, then I've hardly changed anything. But then I note that when I'm summing over these second terms here, I'm summing over dummy variables alpha and gamma. And so I can swap them because they're just dummy variables. I could call them P and Q, or I could call them gamma and alpha. And similarly, I can do that here for beta and gamma. So I end up with, and because the order of the derivatives doesn't matter, I can just take them out collectively. And now because these two are the antisymmetric tensor with just two of the terms swapped, they must be zero. The sum of them must be zero, so that's zero. So we immediately have this first Maxwell's equation simply because we've written our electromagnetic field tensor as this particular form of derivatives of the potential, which is exactly the same kind of thing that happened when we were talking about three vectors. Now let's show that this Maxwell's equation here gives us this one. And what we've got here you can see is just the same as this definition except both indices are up. Now if I contract this with the metric, I can raise the alpha index up, and if I contract it with another metric, I can raise the beta index up. And if I do the same on both sides, I'll end up raising up this alpha and this beta and this alpha and this beta. So in fact this is exactly, in other words, just changing notation, this version of the four potential equation is precisely this Maxwell equation. So all we need is this equation here. And we can see now some of the power of writing all our physical laws in terms of tensor relationships. Tensors, by their very definition, transform properly as you change between reference frames. And so now we cannot write down any law that doesn't obey the principles of special relativity if we're writing in tensor form. And so as we put more and more of the physics built into our mathematics, automatic properties of our mathematics, then the equations that we write down have to say less and less. And so they're saying very precise things about particular pieces of physics rather than precise things couched in ways that also obey lots of other principles. And so we can see here that all of Maxwell's equations actually comes down to one simple equation.